Good morning, folks. Hope everybody's doing okay today. Uh, anyway, we'll get going here. First off, I'm going to ask if anybody cannot hear me, so I'll send that as a text message just to make sure. So send me a chat if you're not hearing me. Okay? If you cannot hear me. Okay, looks like we're good there. Next thing is if anybody has anything they want to say. It's been since Wednesday. Oh, Keon. Okay, I think you mean you can hear me. So, all right. Anyway, I just oh, what's this? Oh, somebody's having trouble getting in. Let's see if I can help them out here. Just a second, please, guys. Excuse me, folks. This is going to take a second. I need to send somebody an invite to be able to log in. So, and I have to hunt up their email address. Okay, never mind. They were able to do it. Okay, so back to here again. Let's see, Keon, you're still saying you can't hear me, I think. Okay, I'll try it again. Has anybody got anything on their mind? Maybe not class related, but just going on in your lives you want to talk about or anything? Group hug or whatever? Okay, well, I was looking at the numbers yesterday, and they are still exponential for Illinois. So roughly doubling number of cases every 5 days or so. So anyway, oh, I hear some noise. Somebody must have got in. Keon, can you hear me now?
Yes, I can hear you.
Okay, cool. Okay, now you can mute your microphone, please. Anyway, or wait a minute, I don't think you can if you're on your phone, so don't worry about it. Anyway, is there any questions regarding the class? Anything? Nope, not seeing anything. Okay, so in that case, I will go to sharing my screen and we'll take a look at Blackboard, see if there's anything we need to think about there. Okay, so going down the list here, announcements, nothing new, peer mentor. I don't know if anybody has joined Alvaro on that, but he is available. So, you know, you want to do that. Can't remember who I sent the wrong times out for. I don't think it's you guys, though. I think it was the 140. So, anyway, go by what he's telling you the times are, not me. Then I went in and I updated the task a little bit. There isn't much to say, really. We had our exam on Wednesday. We had a holiday on Friday. You've got a lab report due today for the oxidation reduction simulation. The topic introduction and homework for chapter 16 is due on Saturday. I moved it a little bit just to make sure you guys had plenty of time. And still yet, you know, final exam. So I'll be putting some more stuff in here as I get a chance to. So then I guess the next thing would be the sapling. I've already talked about it. So there you go. So the thermo stuff is due on Saturday. So going back to here, has anybody got any questions or comments now before we go on to the lab? Okay, not hearing anything. So we'll take a look at the lab and then you guys can get started. Actually, I think I need to put some of you guys in your lab groups. So that came in a little bit later. Yeah, I got a couple folks. I'm gonna go ahead and move them over before we start that.
Question, when
Yeah,
will our test be for chapter 14?
that's a great question. I don't know if we're going to have another exam before the final or not. Okay, I haven't quite decided if that's a good idea. And that's what you're
Yeah.
asking.
So I know, cause like you said you were talking about the numbers being still pretty high for like the cases.
Mm-hmm.
So if it happens that we're still not able to go to campus, like for our final, will we have to do it through sapling?
Yep. Oh, okay. Yeah, that is a bit of news. I'm glad you mentioned that. You will not be coming back to campus for final or anything else for this semester. The semester is going to finish out online for sure. The school announced that, but maybe didn't tell you guys. They also announced that summer will be online. So if you have signed up for a summer class, it will occur online. So there you go.
Another question, sorry. So I know you said for this year we were supposed to do like the group experiment on the lab, like so that's like voided from our grade, right? Or do we still have to do it online?
Okay, now I don't think I followed you. Would you hit me with that again, please?
Sorry. So I remember at the beginning of the semester you mentioned that as a group, like our lab group, we were gonna create like a lab.
Oh, that thing. Okay. Obviously, you guys. Well, I haven't figured that out. If I can come up with something that would work, you know, we can try it. Um, I won't. It won't be a last minute deal. So I'll get that figured out here real soon. I can't think of how you guys could do an actual real experiment. Yeah, you know, at home. Um, although maybe you could. I don't know. But maybe we can do something else. So I don't know yet. I'm sorry. Okay. Okay, now back to what I was going to do. I have a couple people that came in later. I need to put them in their groups, so that'll take a moment. Okay, I think I got everybody in the right spot. Let's take a look at the lab then. So I'll need to share my screen for that. So, of course, to get to the lab, you go to course materials, as always, down to lab reports. In your view, the only thing you should be able to see is the oxidation reduction simulation that you need to report in tonight. Excuse me. And then the new lab we're doing today, voltaic cells simulation. So the instructions for the simulation is that PDF file that has the link there. And then it says follow the instructions on the attached file, produce a lab report with these items, title, date, partners, data table for potentials, data table for observations. You got 4 discussion questions. How does trading the substances in the beaker affect the potential? And then the next one would be how does changing the concentrations affect the potential? And then how does using the same substance in both beakers but at different concentrations affect the potential? And the last one was how does changing the substance in one beaker affect the potential? And then comments. And so now if we click on the link, we'll get the instructions. So this activity simulates an electrochemical cell consisting of an oxidation reduction reaction where the oxidation occurs in one beaker and the reduction occurs in a different beaker. A wire connects the metals or the metal in one beaker to the metal in the other beaker and allows electrons to flow between. Each beaker also contains a solution of an ionic compound where the cation is the same element as the metal in the beaker. These 2 solutions normally have the same concentrations, but we are going to be doing an experiment where they don't also. A tube between the 2 beakers is filled with an ionic compound mixed in a gel, allowing ions to remain in balance in the 2 beakers. The wire connecting the 2 metals has a voltmeter in parallel that measures the electrical potential of the electrochemical cell. The voltage measured depends on the choice of the oxidation reaction and the reduction reaction. If the voltmeters connect properly, a voltaic cell will have a positive potential. To run the simulation, go to the URL, and then there's the link, and then below that, it tells you how to do it. You will have to activate Adobe Flash to run it on your computer, unless you have the security settings totally turned off or something. So this first one, you're doing a voltaic cell using copper and silver. Both are at a concentration of 1 molar. And then it just takes you through the steps, and the simulation takes you through the steps. So tell you what, I think I'm just going to flip back and forth between that and show you how it's going to look. So if I click here on the simulation, you're going to get this thing. And so it starts out, first off says, click on the metals tab on the right side of the page, select copper, close the tabs, click on the solutions tab on the right, select copper nitrate, close the tab, confirm the molarity is 1 molar. So let's look at that real quick. So here is the metals tab. Going to click on that. We want copper, and then close the tab, and then we want copper nitrate. So we click here, and then we close the tab there. We look, make sure it's 1 molar. Now going back to the instructions, on the, you see, click on the metals tab on the left, select silver, close the tab, select silver nitrate, close the tab, confirm it's 1 molar. So going back, oops, I lost it. Where is it? Oh, there it is. No, that's not it. That's not it. Here, there you go. Okay, so this time we're going to do silver. So we click on the tab, pick silver, close the tab, click on the next tab, click silver nitrate, close the tab, make sure it's 1 molar. The last step is you flip the switch and it's going to do the measurement. It's going to finish connecting this together. The things you're looking for is this light here is going to come on if this thing works. You're also going to see a potential on the voltmeter. There's going to be a animation of the cations either being formed or being converted into metal down into solutions. And let's just go ahead and run it. So you can see the light comes on, electrons are flowing through the wire from right to left. If we look down here at the bottom where the cations over here where the oxidation is occurring, we're making copper cations. And on the other side, we're taking the silver cations and making them into silver metal. And there's these molecular level animations. So there is copper metal becoming copper cation going out into the solution. And on the other side, we have silver cations out in the metal becoming, or out in the solution, becoming more of the silver metal. And because we are producing cations on the right side and then pushing them over to and becoming silver metal on the left side, then within this tube, this is the tube that has the gel with the ionic compound, the positive ions are moving from right to left, and then there's negative ions moving the opposite direction. That maintains the ion balance between those. So then going back to the instructions, then you're going to record that information in a data table like you have here. Oops. Well, guys, I messed up. Okay, the potentials are already there. You just make sure they're right. How about that? Oh, God. Anyway, yeah, that happens when you do these late at night. Well, anyway, that's where the potential goes. And then you've got observations like for the first experiment here, you're going to record whether the light came on, what's the flow of the electrons in the wire, what's the flow of the cations in the beaker. And then you're going to change the conditions and go through all these other experiments. So hopefully that makes sense to everyone. But I'll kill this and ask, has anybody got a question on how to do this? Kim, I know crashed 3 days ago, so I'm using my backup laptop. That chat sure went away fast. Okay, yeah, that's fine, Keon. Do what you need to do. He's checking out of one computer and checking into another. So you guys in group one, he'll disappear for a little bit. Well, has anybody got a question? If not, I'll go ahead and activate the groups and you guys can go ahead and get going. Once you're done with the labs, of course, you are free to leave unless you have